So today we're going to be covering the lesson Finding Real Zeros. An important part of this is the factor theorem, which states that x minus c is a factor of f of x if and only if f of c equals 0. This method is most commonly used in polynomials with a degree of 3 or higher. So an important thing to notice about the polynomial itself is that the degree of the polynomial is going to determine how many zeros the polynomial has. Whether they are real or complicated is what we're going to find out. And for the sake of this lesson, we are just going to find for the real zeros. And we can solve for this by plugging in potential factors through long division or synthetic division. We're going to go over both, but for now we're going to go with long division as our first. And 1 is a seemingly low number, so we are going to solve for x minus 1. As our first potential zero. So because the remainder equals 0, this in a way proves that x minus 1 is a factor of the polynomial x cubed plus 5x squared plus x minus 6. But in addition to that, it also broke down the polynomial and to x squared plus 5x plus 6. And through this, we can find out what the other two factors are. So you could break it down through the quadratic equation, or you can simply factor it out. So for the sake of time, we're going to factor it out, and that comes out to x plus 2 times x plus 3. And another way you can check for the remainder is another way you can check to see if the factor you've chosen is in fact a real zero. You can plug in the potential factor into the polynomial itself. So you could plug in f of 1 into the original equation, and if it comes out to 0, then it is a factor. But you use long division and synthetic division to break down the polynomial so that you can find the other real zeros. So for example, we will use x plus 2 to prove synthetic division, and we'll plug in the factor -3 into the original equation. So first we will go with synthetic division of x plus 2. Alright, and then we will use the factor x plus 3 for synthetic division. And so because we already broke down the polynomial itself, we don't necessarily need to plug this into we don't need to do synthetic division to the original, but plugging into the original or the broken down form of the polynomial works equally, it works the same. And this is how you find the real zeros of a polynomial.